Hey, this is Mr. Coker with Geometry Lesson 2-4, Similarity. So, we're going to start by talking about what similarity is in the context of similar triangles. So, if you have two polygons, and in my examples they're going to be triangles, but it works for, in general, two polygons, that have two proportionate sides and one congruent angle, then the objects are similar. So if we're talking about a triangle, about two triangles, we can check to see if these are similar. So let me start by reminding you the definition of congruent. Congruent means the same size and shape. When we're talking about angles, it's talking about being the same measurement. Similar, if you say two objects are similar, means that they have the same shape, but not the same size. So that's why if they're in proportion with each other, they're still similar, even though they're not the same size. To check similarity, the first thing I want to look at is that we have one angle which is the same. So we have this angle, these are both right triangles, so they have one 90-degree angle. So those are, of course, the same. Let's look at the sides. One has a side of 2 and a side of 3. The other one has a side of 4 and a side of 6. We can check this in setting it up in a few different ways. The way I'm going to do it, I'm going to start with our larger triangle, and I'm going to take one of our sides and put it in a fraction over its corresponding side. So 4 over 2, we're going to see, does that equal 6 over 3? You can set this up, I believe, in 4 different ways. However, any of them will work as long as you set them up correctly. So the way I have it, again, 4 over 2 equals 6 over 3. There are 2 ways you can check this once it's set up, or 2 really good ways. One way is to divide. 4 divided by 2 equals 2. 6 divided by 3 also equals 2, so we know these are proportionate. The other way, and especially when you get to harder to divide numbers, the easiest way to do this is to cross multiply. 3 times 4 is 12, 2 times 6 is 12. So again, it shows that they're proportionate, and therefore these are similar triangles. So they're similar because they have a side, then an angle, and the side, which are either congruent or are proportionate with each other. Now that is one of our postulates. And what do you know? We have a list of postulates over here. So the first one, postulates, are kind of meaning rules that show similarity. So the first one we have is angle, angle, which can also be written as AA for an abbreviation. And what that's saying is if we have 2 angles which are the same, so if you look at these 2 triangles, these angles are congruent, and then these angles are also congruent. If a triangle has 2 angles which are the same, then that automatically means that they're similar, because a triangle has 180 degrees no matter what. If 2 of the angles are the same, by definition the third one must also be the same. So angle, angle, if you have 2 angles which are congruent, then it's similar. The 2 triangles are similar. The second one is the one we just used in our example, side, angle, side. So here we have another pair of triangles, and we have a side, an angle, and a side, an angle, and a side. The angles again are congruent, so that checks off. The angle is congruent. We can check the sides by doing, again, 9/6 and 6/4. Again, the best way to do this is just to cross multiply. 4 times 9 is 36. 6 times 6 is 36. So the sides check out. So that's an easy way to check and see that these are actually similar. So we've done angle, angle, and side, angle, side. Now let's do the next one. The next one is side, side, side. SSS. So we've got one here where we have a triangle that has sides of 1, 2, and 4, and then sides of 2, 4, and 8. Now you can probably do the math in your head and you see that and you say, oh, well that's clearly twice as big. But we can check that. The best way to do it when we have 3 of them is going to be to divide. So I'm going to do 8 divided by 4. 8 divided by 4 is 2. So these sides, well, we don't know yet, but they are going to be, of course, similar. 4 divided by 2 also is 2. And then 2 divided by 1 is also 2. So all 3 give us the same numbers. So side, 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 they all check off. And that's, by definition, what a similar triangle is, means it's the same shape. So if all 3 sides are the same, or proportionate to each other, then they're obviously the same shape, but different sizes. Okay. So that is similarity. The last thing I want you to go through is if we're finding a missing side. Now I'm going to go back here. Let's say we know these 2 triangles are similar. So we know these 2 triangles are similar, but we're given that information, but we don't know what one of our sides are. Now, just as we checked by cross multiplying, we can do the same thing to solve a missing side. 4 divided by 2 equals 6 divided by x. And just like we cross multiplied, we cross multiply again. 2 times 6 equals 4 times x. 2 times 6 is 12. 4 times x is 4x. One-step equation now. Divide each side by 4. And we get x, of course, equals 3, which we already knew. We already knew that x equaled 3. But if we are not given that information, that's how you find it. Set up your proportions, make sure you set them up correctly, cross multiply, and then solve the equation. So anyway, that's similarity. It's a lot of information. The main thing to remember is remembering the postulates and remembering how to set up your proportions. If you can do that, this shouldn't be too difficult. So thanks for watching.